Okay, see Lindelof, AP Calculus exam prep. What I've done is I've gone through all the exams, all the AP exams for the last 10 years, and I found the problems that show up most often. So this is a problem I want to go over today, and this problem is going to show up in one form or the other with about, you can be about 80% certain that you're going to see this. So here's the problem that we have. So here's a problem that we have. A water tank, the water tank at Camp Newton holds 1,200 gallons of water at t equals 0. During the time interval t is greater than or equal to 0 and less than or equal to 18 hours. Water is pumped in at a rate. So this is really, really important here, that when we're looking at this, we're looking at a rate. So I'm going to just underline this word rate right here because I want to know that these are rates. During the same time interval, water is removed from the tank at a rate. So here's another rate. And it wants to know, is the amount of water in the tank increasing at t is equal to 15? Why or why not? So all I'm going to do is this. I'm going to take these two equations, right? And I'm going to figure out, well, what's the combined rate of water going in or out of the thing at t is equal to 15? So I'm going to do this. I'm going to say that this is all I'm going to put up. So I'm going to write A here for my answer, A, so my reader knows where I am. Say A, and I'm going to do W of 15 minus R of 15, the rate here, is equal to, and I'm going to come up with this number. I'm going to show you how I did this in a second, but I'm going to come up with this number, and the number I came up with was negative 121.09. And all I'm going to say is that it's less than 0. So the amount of water is not increasing. And this is what I did here. I went to my calculator, because this is a calculator section. I went to my calculator here, and I looked at this thing, and I was like, you know what, I'm going to need these functions anyway. So I typed the functions in. So the functions were 95 times square root x, right? Use your cursor to get out from underneath that radical, times, and here it's sine squared. This is something you really have to get here, is that when you're going to do sine squared, your calculator prefers to see it this way. So I open the parentheses, I put in sine, right? I put in sine, and then I'll put in my argument, which is x6, so control division, x over 6. This is the important part. Then I'm going to go out to here. I'm going to put this other set of parentheses in here. So I have two sets of parentheses, and I'm going to put that value squared. You see that? It's really, really important. So usually we take the sine, we take sine squared, but your calculator doesn't like it. So we know that sine squared of a value is sine of that value times sine of that value. So I'm going to take it that way. I'm going to hit Control, Store, and I'm just going to call this W of X, if you don't mind. Hit enter. Seems kind of dumb, but I'm building this right now. I'm paying kind of up front because I'm going to use these again and again. So I'm going to go ahead and put in the second function, which is 275, which is 275 times, and again, open this up, and it is sine squared of t thirds. So I'm going to put in sine. You can go here to trig with sine. So x thirds here. Again, look what I'm doing here. I'm going to go out here. I'm going to build those parentheses. I'm going to build the other set of parentheses, and I'm going to put that squared. I know you're going, damn, this takes a long time. But once we get this, we're going to use it for the next four parts of the problem. So it's going to save us a ton of time in the long run. And I'm going to say this is r of x. I could have used t, but if I use t, I'd have to use t here and here and here. So I started with x. So I just stayed with it, right? And now all I'm going to do is this. I'm going to ask the question. Remember what our answer was. That our answer was this, right? So here's our answer right here. And this is how I got that answer. So I just went here and I took W of 15 minus R of 15, hit equals, and we have that number. All right, so we got this. So this is the amount of water coming in, the rate of water coming in. This is the rate of water coming out. And the rate going out is greater than the rate going in, so the level of water is not increasing. So that's how I got that answer. So we go back now to the second part of the question. The second part of the question, so we answered this part right here. If we go back to the second part of the question, it says, to the nearest whole number, how many gallons are in the tank at t equals 18? So here's the notation that you have to use. You have to keep in mind, a little bit of something in mind. How much water is in the tank? Well, the amount of water in the tank, so this is what I'm going to do. I'm going to say that the amount of water in the tank, you don't have to use this notation, but the amount of water in the tank is, remember, it said that at time is 0, there are already 1,200 gallons, right? Plus the amount of water that went in there from time was 0 to time was 18, right? Because that's the question. And then we have W, I was using X, but WT minus R of T dt. That's all you have to put in for your notation, right? And this is the amount of water going in and coming out. And when we take when we take the antiderivative here, when we integrate this, we get the total amount, accumulated amount of water plus the 1,200 that we started with. And if you did that, you would get a total amount of, it says round to the nearest gallon, so you get 1,310 gallons. So this is what your answer should look like, right? So this is what your answer should look like here. How would you get that? It's actually pretty simple. And remember that we put all this stuff into the calculator before, and I said that we go back and use it again, and we're going to. We're going to put in here 1,200 plus, go to menu, go to calculus, go to integral, and it's 0 to 18 is what we put in, isn't it? And you can just use your cursor here to go up and pay attention to where it ends up. So it's here to 18. And then this is where it gets actually pretty easy, because we're going to do, remember I put this in terms of x, so W x minus R of x, and then this is really important, that the argument is in terms of x, so the derivative has to be in terms of x here. Hit enter, and there's that proof. It said round to the nearest gallon, so this is what's here on the left-hand side. This is what I would put in to my paper to show them what the calculus was. But I'm saying to you, you already built these things in here, so you can do this really easily, can't you? All right, so that's how I got that part of the answer. Go back to the question. Go back to the question. And so we got this part done. So now we're on this part. So it said, what time for t is greater than or equal to 0 and less than or equal to 18 is the amount of water in the tank at its absolute minimum. So it's at its absolute minimum. Show the work that leads to your conclusion. Well, remember that it's going to happen at either the endpoints or a critical value. So all I'm going to do is this. Remember, these things are rates. So all I'm going to do is this. This is really, really easy. In my notation, for C, I'm going to write C that when is W of t minus R of t equal to 0, right? Remember, these are rates, so we want to know when is this rate minus this rate 0? When are the rates equal to one another? Right? That sounds simple enough, and it is. I'm going to create this little thing here. And I'm going to, in my thing, I'm going to put here t, and here I'm going to put in gallons of water. First thing I'm going to do is this. Go back to my calculator. I'm just going to ask the calculator this question. So back to the calculator, and I'm going to use my solve function. So S-O-L-V-E, solve, and then I'm going to ask that question. When is W of x minus R of x, right? Minus R of x equal to 0. Remember, comma x. So it means in terms of x, hit enter. I get this questionable accuracy thing down here, they're covering their behinds, but it's fine. We know where we're looking for. And look, it says x is 0, but that's one of the endpoints, right, that we used anyway. The other one is this point, and the other one is this point. We go to x is equal to 24, and we could keep going. But it says clearly that we don't want that. We want values between 0 and 18. So we have, so what I'm going to do is I'm going to capture this one and this one, right? So I'm going to go back to my paper, and I'm going to start to put these values in. The first value is 0, right? That because it's an endpoint, and gallons of water is 1,200 because we know that right? The other one we got was 6.495. The next one we got, if we go back and look at the calculator, was this one, 12.975, because I'm going to round to the thousandths place. So I'm going to go back to my paper. I'm going to show that to my reader, 12.975. And then remember, we have 18 is an endpoint, isn't it? Now what we have to do is this. This is where it gets a little bit trickier. Remember, we have to use this equation to figure out how much water there was. We want 1,200 plus 0 to A, 0 to these four values of WT minus R of T dt, right? So I'm actually going to go back and I'm going to do that. The first one's a pain in the neck, and then it gets really, really easy. So I'm going to do that. I'm going to do 1,200 plus menu, right? Calculus, integral, and I want to start off with 0. And remember that value that we had was 6.495, right? Of, open these up, W of x minus R of x dx. Hit enter. Got 5, I'm going to round to the nearest gallon, so 525 gallons. So check me out here. I'm going to go here. I'm going to put 525. I'm going to go back and do this again. It seems like a pain in the neck, but it's not at all. I'm going to use my cursor here and here. Just hit the up cursor. Look, hit enter, right? If you do that, if you go back and cover this with your cursor, hit enter, it retypes it here, and now you can edit this. So all I'm going to do is walk back to this value here. I'll walk back to this value up here. I'm going to take this value, take this value out and put my new value in. The new value that I wanted to put in was 12.975, so 12.975. Hit enter. 1,697 gallons. Go back to my paper. 1,697 gallons. Last one I'm going to do is 18. Exactly the same way. Exactly the same way. Go to here, hit my up cursor twice, hit enter, it retyped it here. Going to go back here. Look, this is this fast. So I'm saying if you build this thing correctly, it gets really, really fast. Take this thing back, put in 18, 18, hit enter, gives us 1,310 gallons. 1,310 gallons. So now what's the lowest value? So T equals 6.495 is absolute minimum, because minimums or maximums, but minimums occur at endpoints or critical values. All right? So I think that should really sum this up. So I hope this was helpful. You're going to see a problem like this on exams, so you should be looking at these problems. They're on tons of exams. If you have any questions or comments, please let me know. Hey, if you haven't already subscribed, please subscribe. I really appreciate it. Thanks, you guys. Peace.